You have two elements that repeat, and the smallest possible rearrangement wins. Fix all but the two middle characters as their sorted smallest form, and put the two smallest value distinct letters in the very center to keep it a palindrome. In short, given a string that's already a palindrome, find the alphabetically smallest way to rearrange its letters so the result is still a palindrome. Beginner level, here's a string. A string just means a row of letters like babab. The cool part, you only need to figure out the first half of it. The second half copies the first half automatically every single time. Even if the string has 100,000 letters, you still only think about half of them. By the end of this video, you'll be able to spot this trick right away. You know how your phone's autocorrect finds the closest real word to what you typed? That's basically what we're doing here, just with palindromes instead of words. A palindrome is a word or string that reads the same forwards and backwards, like mom or babab. Scientists actually use this same idea to fix mistakes in DNA. One simple trick, two totally different jobs. Let's slow down and look at exactly what we're asked to do. We're given a string that is already a palindrome, like babab. Our job is to rearrange those same letters into the smallest possible palindrome. Smallest here means alphabetically first, like how apple comes before banana in a dictionary. We're not adding or removing any letters, just putting them in the best order. For babab, the smallest palindrome we can make is ababa. Don't worry, we only need a few simple tools. First, a hash map. Think of it as a tally sheet, like counting votes. It just tells you how many of each letter you have. Second, we'll sort those letters from A to Z, the same way you would alphabetize a list of names. Third, we glue pieces of string together. That's genuinely everything we need, nothing fancy. You might think, why not just try every possible order of the letters, called permutations? Keep only the ones that are palindromes, and pick the smallest. That's a totally reasonable first idea, and for a short string like babab, it would even work. But here's the problem. As the string gets longer, the number of possible orderings grows insanely fast. For a 100,000 letter string, there would be more possible arrangements than atoms in the entire universe. Our computer would never finish. Here's the big idea, and once it clicks, everything else is easy. A palindrome is just its left half copied backwards to make the right half. Picture a mirror standing in the middle of the string. Whatever's on the left automatically appears flipped on the right. So if we build the smallest possible left half, we automatically get the smallest possible whole palindrome. I like to call this the half and mirror trick. Count the letters, split each count in half, sort them, and you're done. First step, count how many times each letter shows up. In Python, there's a ready-made tool for this called counter. You give it the string and it hands back a tally, like A appears 2 times, B appears 3 times. Because our input is already a palindrome, almost every letter count will be an even number. At most, own letter will have an odd count, and that letter will end up sitting in the very middle. Now we go through our letters in alphabetical order. A, then B, then C, and so on. Because putting the smallest letters first is exactly what makes the final answer as small as possible. For each letter we check, is its count an odd number? If yes, that's our one special middle letter, so we save it separately. For every other letter, we just take half of its count. Small tip, it's easy to forget to pull out that middle letter separately. I did the first time I wrote this separately. So make sure you handle it before moving on. Last step, and it's short. Take the half we just built, add the middle letter if there is one, then add that same half again but backwards. That backwards copy is our mirror. So really all we ever had to build was the left side. The mirror hands us the right side for free. Let's practice together. Here's the string tacocat. Pause the video right now and try counting the letters, then work out the smallest palindrome you can build. Take your time, there's no rush, and it's totally fine if it takes a couple of tries. Let's check your answer together. Counting tacocat gives us T appears 2 times, A appears 2 times, C appears 2 times, and O appears just once. Since O is the odd one out, it becomes our middle letter. Our smallest half is act, so the finished answer is A, C-D-O-T-C-A, or actotka. If you got that, nice work. You genuinely got the pattern down. For a short word like tacocat, trying every single ordering called brute force would generate 5040 different arrangements. That's a lot, but a computer could still check all of them, filter out the palindromes, and pick the smallest one in a snap. So for small inputs, brute force isn't wrong, it's just wasteful. The problem shows up when strings get much longer, which is exactly what we look at next. Let's put a number on how much slower brute force really is. Programmers describe how an approach scales using something called big O. It's just a way of saying how much more work as the input grows. Brute force costs in Factorial, which means the work multiplies out of control as letters are added. Our half and mirror trick costs just ni, meaning the work grows steadily and predictably. One pass to count, one pass to build. Past just a handful of letters, factorial time doesn't just get slower, it becomes completely impossible to finish, even on a fast computer. Let's make sure our solution holds up in a few unusual situations, often called edge cases. What if the string is just one letter, like eds? Then there's no half at all, and the whole string is just a middle. Our code handles that with zero extra effort. What if every letter is the same, like AAA? Ah, the half becomes AA, and mirroring it gives us back AA. Exactly right. And if the input was already the smallest possible palindrome, we just rebuild it the smallest possible palindrome. We just rebuild it the same answer back. No special extra rules needed anywhere. That's the beauty of this approach. Let's recap what we learned today. Remember that scary permutation explosion from the beginning, where trying every arrangement would take forever? Splitting each letter's count in half and mirroring it is exactly how we dodge that problem. Count the letters, sort them, split each count in half, then mirror it back. That's the entire solution, start to finish. Great job sticking with this one. Tomorrow, same time, we'll use this very same mirroring idea to crack a tougher rearrangement problem. Hit subscribe so you don't miss it. That's the easiest step in this whole video.